This is Math 112, Section 3.5, number 77. Gives you these parametric equations, that x is equal to secant squared of t minus 1, and that y is equal to tangent of t. And we're going to take t from the interval negative pi over 2 to pi over 2. Seeing secant squared and tangent, you want to recall the trig identity tangent squared of t plus 1 is equal to secant squared of t. So we need to fit these parametrics into these forms. X, as you can see, if we move negative 1 to the other side, we'll have that x plus 1 is equal to secant squared, which is already in the form that we need it to be. Y is tangent of t, so it needs to be squared to get in the right form. And now we can just plug these guys in to where they need to go. This gives us the formula that y squared plus 1 is equal to x plus 1. 1's cancel out, leaving you with the equation y squared is equal to x, which you should recognize as a horizontal parabola. So let's graph this horizontal parabola. At y is equal to 0, you get 0. At y is equal to 1, you get 1. Y is equal to negative 1, you get 1. Y is equal to 2, you get x is equal to 4, and y is equal to negative 2. You get the same idea. We're not done because the parametric is only defined certain values, so we need to establish at least a direction. So let's write down our three coordinates. We have t, x, and y. And let's just solve this in general using the borders and look at the end behavior. If x is equal to secant, we know that secant squared, that's really 1 all over cosine squared of t minus 1. Now what happens is when cosine approaches negative pi over t, it's become a really, really small negative number. It doesn't matter because when it's squared, it becomes a really small positive number. 1 divided by a really small positive number is going to be a quantity near infinity, minus 1. So pretty much still infinity. Y is going to also approach undefined, which is going to be secant squared, not secant at all, cosine all over cosine. Let's take a look what happens here. Sine is going to be approaching 1 at negative 1 at pi over 2, and cosine is going to be approaching 0. So what you'll get is a positive number divided by a negative number divided by a really, really small positive number. So you're going to get a quantity nearing negative infinity. Okay. Now let's take a look at 0. Cosine of 0 will just be 1. 1 divided by 1 minus 1. Well, sorry, 1 squared. And then 1 divided by 1 squared minus 1 is just 0. And y approaching tangent is just 0 as well. And finally, let's go to pi over 2. Pi over 2 will pretty much do the same thing for this quantity because it's squared. You're just going to get a really small positive number approaching 0 squared, which is still a positive number. 1 divided that will give you a really big number, minus 1. And this time tangent will be approaching positive 1 all over 0, so giving you a really big positive number. So you can see that we start here, moving towards 0, and then going off into positive infinity. And this is problem 77.